right, number 20. So we got a rifle with a weight of 30 newtons. Now look, we're going to need mass here. So 30 newtons is the weight. So W equals mg. You guys know a lot more physics than you may think at this point. You already learned this. So weight is the 30 newtons. Remember what a newton is? A newton is a kilogram meter per second squared. Gravity is 9.8 meter per second squared. So the meter per second squareds, they cancel, and we get 3.06 kilograms. So that's the mass of this rifle. So I'm going to call the rifle, let's say that the rifle is object 2. The rifle is object 2, 3.06 kilograms. And then the bullet, which we can't see because it's inside the rifle. So inside the rifle, here we go. We're going to open the rifle up. There we go. What's inside the rifle? The bullet. Here it is. Boom. He's sitting right there. There's the bullet. M1 and 5 grams, which is 0.005 kilograms, right? 1,000 grams in a kilogram. All right. What's the initial velocity of the rifle? V2 initial. What's the rifle doing before the bullet gets fired? Sitting there. It's 0. What's the initial velocity of the bullet? 0. The rifle and the bullet are initially at rest. Okay? So this is a situation where you can use conservation of momentum. You can use conservation of momentum for collisions and explosions. And what do we mean by explosion? We mean two things pushing apart, which is basically a bullet being fired by a gun. When you fire this gun, is the gun just going to sit there? Or is it going to go back? It's going to go back. Okay? You guys know what I'm talking about? Just imagine a big, big, big mama gun. You know, not a little BB gun. You know, BB gun, you're not going to really notice it. But if you fire like a giant cannon, you know, the cannonball goes one way. What happens to the cannon? It goes back. Okay, so it's an explosion. Two things pushing apart. Same thing as like two people pushing each other on a frozen lake. Okay? All right, so here's the conservation of momentum equation. And just so you understand this,
Isn't recoil usually upward though?
no, I mean, recoil is like in the opposite direction of which way the bullet goes. So if the bullet goes to the right, the gun recoils to the left. Or like if somebody vomits to the left, you're going to recoil to the right. You're like, oh, recoil just means to go away, to go back. Okay? That was a bad example. Okay. All right, look at, what's the initial momentum of the bullet? 0. What's the initial momentum of the gun? 0. We're starting with no momentum. If we start with no momentum, we need to end with no momentum. Well, how is that possible? Well, it's possible because, look at, the bullet goes one way, the gun goes the other. So their momentums after the bullet's fired will cancel each other, right? The two momentums, the momentum of the bullet is positive, the momentum of the gun is negative, and they have to be equal. So if you rearrange this equation, what you're going to get is M1 V1 final absolute valued equals M2 V2 final. If you just focus on the absolute value. Now, what are we looking for? We are looking for the final velocity of the rifle, which is V2 final. So V2 final is going to be M1 V1 final over M2, and we have all this. So we know the velocity of the bullet. They tell it right here, 300. So this is going to be 0.005 kilograms. The velocity of the bullet after being fired is 300. And then the mass of the gun is 3.06. So then the kilograms cancel. And V2 final comes out as 0.49. Who got that right? Nice. Nice.
Are these types of questions in your math school?
On the quiz?
Yeah.
Oh, definitely.
This particular one, or one similar to.
Definitely. That's why we're going over it right now. Yeah, I'll stick this online. Okay. Part B. Hey, who can tell me what changes in Part B? There's only one thing that changes. The mass of the what? Of the gun. So basically, here, let me just refresh this. Okay, so basically, instead of this picture, you're going to be so amazed. I have another picture for you. So instead of that picture, we now have this guy here. Yeah, he does. Okay, so now instead of just the gun, it's the guy. So look, we're almost out of time here. So these are still 0. 0 and 0. So M1 V1 final absolute value equals M2 V2 final. So we're looking for the velocity of the man and the rifle. So V2 final is going to be M1 V1 final, or M2. Same thing. Mass of the bullet is still the same. Velocity of the bullet still the same. So what's the total weight of this guy? 730 newtons. So divide that by 9.8. And the total mass now is 74.49. So the only thing that changes is the mass of the rifle goes up because now the guy is holding it. So V2 final becomes 0.02. You get that one right? Who got that one right?